Hello everyone. My name's Andrew Addison. I'm the technologist for Boston Limited. We've got a broad church of skills that we have. I bring the software into the game. I have 30 plus years of software engineering experience actually in the financial services industry, and I've dealt with high performance computing for Merrill Lynch, JP Morgan, Bank of America, loads of the big banks, and a number of hedge funds. What I've found is a general thing that's been happening in the early days is that we'll be bringing new types of hardware into the folds to handle compute, because that's basically, as a computational scientist, is what I really care about more than anything else. So just a really very light chat here, so we can actually go and follow up with some details. Obviously, high performance computing means a number of things. It used to be just the CPUs. We've got GPUs in there. For analytics, for banking, we're generally stuck with the CPU's end of it. But as more demands have increased over time, you have to start incorporating things where the CPU will not actually do what you need it to do. You need to make it cover the more broader church of what's going on. So we're using the power of supercomputers. We supply hardware for companies like CERN and data-intensive problems. So we're not only interested in the compute, we're also interested in where the data sits, the throughput of it. So in banking, we would call that high throughput rather than HPC. It seems to be a common term we'd use in science. The analytics themselves can be absolutely huge. So individual analytics in the bank would be gigabytes. And you might only have to start up the instances one at a time. So you've got a very, very large problem to do with compute and data, a very heady mix. For certain types of compute, you can't just do them. You can do them with GPUs if you're doing vector calculations, but if you're doing graphs, you have to start using a slightly different mix of it. And in Boston, we've got a couple of labs actually. One where we do have graph execution engines. We use AI solutions and a whole series of them, which I'll come to a little bit later. It's working now, thank you. So AI. Interesting stuff, because a lot of AI that people have been using is actually business informatics, and it's a matter of actually making your data work harder. I think one of the reasons it's become quite significant and statistics has become such a big thing is that data's become quite cheap and computers become quite inexpensive, and then we have to start and get back to the old problem in the first place of how we go and deal with these different types of workloads. Now, for AI, a lot of it can be done with GPU. Some of it can be used with other complementary technologies, and we also create them. I actually build some of the prototypes that we actually have in the labs, which we then turn into products and help the customer whatever they need. So the idea is we're augmenting a decision-making process. I just wanted to just sort of touch on that a little bit more. We have a number of projects which we work on with AI, where we're actually looking for anomalies in the liver, for instance, and trying to classify them in certain types of early forms of cancer. We're working with the King's College University Hospital and a number of other universities, so we can actually go and enhance how we go and work on that. The algorithms, they're hard to train. We run the kind of UNet kind of world, if anyone's familiar with that kind of stuff. But ultimately, it's, in that particular use case, is to help a human being make a decision. It's not replacing a human, probably like Musk would go on about. It's actually to augment the process. It exists for a reason. We want people making a high-level decision and be well informed from a lot of high-quality information. Now, the other thing about AI, with statistics, it's deterministic. You can prove it's right. And when you start using black boxes and you start emulating nature, and you're using neural nets or spiking neural networks or convolutional neural networks, ultimately, it's a bit harder to work out what's going on. So we have a series of solutions where we deal with the workflow of it. So rather than a software engineering, software development life cycle, we can actually talk about managing and testing models using the scientific method on your model, monitoring the model and curating it. And I've done a lot of work in that space, again, in the labs for that. We're with a company called D-Cube to handle the flow. And quantum. Now, this is one of the things I've been involved with for about over 5 years now. I'm actually involved with the startups we've got. There are so many different types of quantum, it's a bit crazy. You've got cold quantum, you have photonic, you have ion pump, and a whole series of bits in between. With equally, all with their different challenges. Photonics has a lot of problem to do with detection of the photons off the back of it. Obviously the fabrication. Cold quantum has other issues to do physically. You end up with a large data center in there. This is with Oxford Quantum Circuits. We're partnered with them. In fact, I did a video with them yesterday about our partnership. We happen to have one of our labs, which actually the one I use mainly, is actually right next to where they manufacture it. We've got a number of Oxford Quantum Circuits machines in there, and we talk with the scientists to see how we can work with the algorithms, because obviously we've got a team of quantum algorithm developers linked with Cambridge University, lovely bunch, and we're looking how we'd mix quantum with AI quantum hybrid workflows, which is possible, believe it or not. And I did a video on that, how to use it with image classification. Very straightforward if you're all into Hilbert space stuff. Very, very interesting. Yeah, so we're going to mix it in the pipeline. Now, the reason you're using quantum is because the CPU is very, very bad at doing NP-hard problems. And as a computer scientist, I used to write compilers. You're always looking out for that evil bit, even in compilation. But if you look at certain classifications of functions and you get a little fingerprint for them, because I'm a compiler writer, you can look at the fingerprint of certain types of functions and you might say that's best suited to that type of processor. And this is where our partnership for AMD is quite interesting, where they've gone full heterogeneous actually on the chip itself, which are the super chips. It's a great way of doing it. But obviously you're very, very dependent on that software layer. And how you go and manage it and how you go and delegate it. And that, for me, is the interesting bit, because that's all I know, really. Well, the numeric bits. So, exponentially faster, but at a price. This is a nascent industry. I mean, 4 or 5 years ago, there were only a handful of quantum computer companies here, and now it's full of them. So I didn't expect to be that many. It's been quite busy. But yeah, very interesting nascent industry. And now we talk about how these all come together. We want a toolbox to solve a problem, and ideally the smarts to make it as easy as possible for the user to not really care about the technology, the implementation of the stuff underneath. But the more different types of variations of AI and compute that you actually have in there, the broad church, you're not really going to care whether it's AI, BI, or an analytic kind of universe if you want general computing. And that's one of the things we're working with Sakai on. So quantum artificial general intelligence is where we want to be kind of heading. And we're many years down the line. It'll be a few years before some of these will actually be used ubiquitously. And one in particular on the quantum side is Sakai. We're doing a lot of work with photonic quantum in that space, which is something which I personally kind of like. So with that one, we can use them in what we call them icing machines. So like to do with annealing processes. So you can find out the minimization functions. And I've been talking with some airlines who are quite interested in using that just to, good old traveling salesman problem to optimize the fuel which they're actually using. And that's in the early stages of conversation. And a few of these quantum computer companies have actually got the machines there, such as OQC. So we actually have access to the machine. But one of the things that I've been working on is with our labs. I need to say this. So we have. It's hard to get a quantum kit, right? And it's hard to find people with the technicians. We also have that within Boston. And we have labs with, a series of labs with a series of these different types of compute, which you can access. You just need to contact us. Actually run stand F40 if anyone wants to talk any more about this, where we can actually bring them in. And we partner with people with the skills. So if we can't answer the question, and if we can't make sure that you get what you need, we know who to talk with, and we know the partners we'd need to bring in to kind of help. And that's kind of like Boston's secret sauce with these particular things. And we have a global presence, by the way. So, I've been building quantum simulators. Now, you're probably wondering why. Well, they're very, very expensive when you use them, and you want to try and experiment, and you hit about an hour, and you've burned $1,000, and gone, oh, well, you don't want to do it like that. So, for the lower quantum volume calculations, for those of you that know quantum, we've been partnered with NVIDIA. I built Q-Quantum, CUDA Quantum, using Qiskit. I'm also looking at Penny Lane as well, because they've all got different types of angles to them. I quite like penny lane because I come from a financial services industry, so if you're doing balancing of equity portfolios and things like that, then you know the library is a little bit easier to use. But it's all maturing quite nicely. I personally quite like Qiskit because it's really good for demos. It's fantastic just to demonstrate, to get the ideas across, to get people into the whole thing. And yes, so that's basically what we actually physically have now. I've got a series of them in two of our labs for that stuff. And I'm about to build a 40 qubit machine, but as a simulation. And again, the idea is you'd try your algorithms out, see how they go. If you want them, then we can let it loose on the OQC box and the other partners we're with, and actually use the physical hardware. And you might have some confidence in your experiment. You'll find the results which you may or may not choose to have, at that point. All right, so there you go. So here's our partnerships. Centre Square probably doesn't look that familiar to people. It used to be 6TeRa, but they've changed the names quite a few times. But they've got it in what's called the Winners Triangle in Reading in the UK. I'm based in the UK. Boston is a global company, by the way. It's now Centre Square. It's the same machine, they just changed the ownership. Okay, and we are with OQC and Sakai, which is a partner company that I work very closely with Rahul Tyagi and the group there. NVIDIA, we're elite partners there. We sell NVIDIA kit globally, integrated with Supermicro, and I suppose you heard recently, Supermicro has announced that they're in a very, very close relationship with NVIDIA, which is lovely, because the founders of Boston have been with Supermicro since day one. And personally, the reason I joined Boston and flipped from banking was to join because Dev was Mr. Supermicro outside. Because in the hedge funds, Supermicro boxes never went wrong. So, and when you get called up at 3 o'clock in the morning because something's gone wrong, you do remember the hardware very, very quickly. Anyway, so they're very good, but the quality control in Boston for putting these system integration stuff together is really, really good. They have a much more stringent process in other areas for that. But yeah, I'll come to that later. Anyway, so there's the ecosystem there. We have a much broader situation in the software space. And obviously I've missed AMD on there, sorry about that. But we have the MI300 at our stand at the moment. I thought if anyone wants to have a look at it, the real deal, the little kind of little finned thing. And there you go. So this is it. We're bringing a new type of compute into the fold. It's reached another generation. There may be others in the future. Who knows? But we want that to be ubiquitous. We want it so that someone can actually use this on a day-to-day basis and basically not worry about the compute. Thank you very much.